Okay, in our final section here, this is using a normal approximation for a binomial distribution. So it's very similar to what we were just doing with all this normal distribution stuff right here. What we're doing here is I'm giving you a binomial distribution type situation where here we know that 30% of gnomes have beard implants. 50 gnomes are selected at random, and then it asks you to use a normal approximation to answer these questions. Now remember, with binomial situations, and those are things where the answer to the question is either yes or no, where you have two possible outcomes. And here the situation is, does the gnome have a beard implant? And in this case, 30% is given, so that is your success rate. Success is having a beard implant, so we know that P is equal to 0.3, which means Q, the failure rate, therefore Q, would equal 0.7, and then I tell you that 50 gnomes are selected, so we know that N is equal to 50. Now remember that with these type situations, if you have a binomial distribution type situation, you can only do a normal approximation if NP is greater than 5 and NQ is greater than 5. So the first thing I'm going to do is actually find what N times P is. So N is 50 times 0.3, and when you punch that in the calculator, you will get 15. And N is 50 times Q, which is 0.7, and when you punch that in, you will get 35. Both of those are larger than 5, which means it's okay to continue and do a excuse me, and do a normal approximation with this situation. Now remember, with a normal distribution, you need to find the mean and the standard deviation. That's how everything is based, on the normal distribution in the bell curve. So my mean is N times P, which is 50 times 0.3, and we've already punched that in. We got 15 from over here. And then my standard deviation is the square root of N times P times Q, and we'll throw that in the calculator. So the square root of N, 50 times P, which is 0.3, and Q, which is 0.7, you get 3.240. So 3.24 is the standard deviation. Then we're going to use that to construct our little bell curve. So let's see, my bell curve, I'm going to draw that real quick. Now this one's going to be a little bit tougher because normally for our bell curves, we can count. The standard deviation is something kind of sexy, like 9, as it was in that last problem. Here, my mean is 15, so that means, well, anyway, that means what? That means the mean's 15. All right, so the mean is 15. The standard deviation is really ugly. I really don't want to count 3.24 off to the right several times and to the left several times. So what I'm going to do is I'm going to draw a normal distribution bell curve here. All right, so it's going to do something like that. And then I'm going to be picky and make this really pretty. So hang on a sec. There we go. So there's our bell curve. And then the first question asks, what is the probability that more than 17 gnomes have beard implants? So out of these 50, what's the probability that more than 17 have beard implants? So 17 is going to be about right here. And the probability that more than 17 have beard implants means I want to know what's the probability that the area to the right, I want to find the area to the right of this region. So I'm looking for all of this region over here. That's the stuff that's more than 17. Now the tricky part about a normal approximation to a binomial distribution is that this is one where you have to find that correction factor. Because with a binomial situation and a normal approximation, there's that weird thing that one allows decimals and the other doesn't, and so we have this thing called a correction factor. And the correction factor is when you move, you have to move either to the left or to the right half a unit. So I'm not actually going to use 17. I'm going to choose either 17.5 or I'm going to use 16.5. You move half a unit either to the left or to the right. And the way you decide which one you're going to use is by deciding whether or not we want to include 17 with the percentage. Now this says the probability, we're wanting the probability that the number of gnomes is greater than 17. Now when it says more than 17, it doesn't say more than or equal to 17. It just says more than 17. So when I find the area to the right, I do not want to include the 17. Well, if I chose 16.5, then when I do the area to the right, I actually am going to include 17, and you don't want to do that. So instead of choosing 16.5, we're going to choose 17.5, because if I find the area, if I find the percent to the right of 17.5, now I'm not including 17, and that's what I want. I don't want to include the 17, so we're going to use 17.5. So use x equals 17.5, and then once you choose your x value, then it's all going to be the same as that last problem, the last situation. We compute the z-score, which is x minus the mean over standard deviation, which is 3.24. So we'll get our z-score, and the z-score is 0.772. And then in the calculator, we will do the normal CDF, norm CDF, and we do -4 comma 0.772. And let's see, when I punch that in, let's go catalog, norm CDF, -4 comma 0.772, I get 0.7799. I get 0.7799, which is 77.99%. Now what you have to remember is that the norm CDF, that tells you the percent that's actually to the left of what you want. So what we just found is actually the percent to the left. To find the percent to the right, if we want to know what's more than 17.5, then we'll actually just do 100% minus that, 77.99. And when I do 100 minus that answer, I get 99.22. Really? Oh, geez. That's not right. I'm such a stupid head. Okay, let's try this again. You get 22.01. So there is your chance, or there's the probability that more than 17 gnomes will have beard implants. All right, so number 7. Okay, number 17, same type situation. Same type situation. I'm going to get rid of a bunch of this stuff up here. Whoa, how many pieces are there? There we are. Let's get, whoa, come on, there. All right, so let's get rid of all this stuff up here, and we have a new question. Number 17 is asking, what is the probability that at least 12 and at most 19 gnomes have a beard implant? So at least 12, so I'm looking as far left as 12 and as far right as 19. And we want the percent that's between those two. So we're looking for the percent between that. And here, for the correction factor, we have to move to either 12.5 or 11.5. We have to go to the left 0.5 units, so 12.5. Well, that would be 11.5 over there, wouldn't it? 11.5, or we're going to go to the right to 12.5. You have to move a half a unit. And then over here, we have to choose between 19.5 on the right, or if I move to the left 1/2 unit, we're at 18.5. And the way we decide what we want to choose is we have to decide whether or not we want to include 12 and 19. Now, when I see at least, to me that means 12 is a desired amount. We're wanting to include 12 because that's the lowest we want to go. So what we're looking for here is the probability that we have at the very least 12, so 12 is less than or equal to the desired number of gnomes with implants, and we want to have at most, and that includes 19. So the probability from 12 to 19, and we do want to include it. So if I want to include 12 and 19, then that means I need to choose 11.5. So I'm going to do the area from 11.5, because if I do that, I will include the 12 all the way over to, and we're going to go to 19.5, because if I go to 19.5, that will include the 19. So we're going to actually go from 11.5 to 19.5. So we're going to use 11.5 and we'll use 19.5, which means we actually need to compute two z-scores. So let's do 11.5. My z-score for 11.5 is 11.5 minus my mean, which is 15, over standard deviation, 3.24. I'm going to go ahead and write down my z-score and stuff for 19.5. 19.5, your z-score is 19.5 minus 15 over 3.24. And then we'll punch those in, and then we'll do norm CDF to get the percentages associated with those. All right, there you go. So you do all of that, you get your z-scores, you punch it in, you do the norm CDF, and you get these percentages. Now remember, when you do the norm CDF, it tells you, when you do -4 to whatever your z-score is, it tells you the percent to the left. So to the left of 11.5 is 14%, so that 14% is actually this stuff over here. And then to the left of 19.5, which would actually be all of this, everything over that way, is 91.8. We need to subtract those two to find the amount between them. So between the two, between 11.5 and 19.5, is going to be 91.8 minus 14, and 91.8 minus 14 is 77.8. So we have a 77.8% chance that at least 12 and at most of 19 of those gnomes have beard implants. So there you go. That's all of it, I'm pretty sure. Yep. Good luck.